So if you could tell me what your name is and what you do.
So I'm Colleen McDowell. I am an assistant professor at the University of Wisconsin-Madison, and my lab studies mouse models of glaucoma as we try to model the disease in an animal where we can look for different molecular pathways that might be leading to disease states.
Why glaucoma?
Well, I actually started in glaucoma research as a graduate student. I got into glaucoma research when I started working with Mike, and he discovered the DBA2J mice model, which was the most commonly used mouse model of glaucoma today. And that's where my career really started. And then I continued on as a postdoc in Texas at the University of North Texas Health Science Center, where I worked with Dr. Abe Clark, and we developed some inducible models of glaucoma. And now I've utilized all of these techniques in my own laboratory, where I look at spontaneous mutations as well as inducible models of glaucoma, and how we can use those models to identify new pathways that might be important in human glaucoma. What we're looking at is the drainage structures in the eye.
Okay.
So in the eye, there's a fluid that nourishes the inside of the eye and helps maintain the pressure, but that fluid needs to drain out of the eye.
Got it.
And it drains out through a tissue called the trabecular meshwork.
Okay.
And in glaucoma, what happens is that trabecular meshwork becomes damaged or impeded, so then that fluid can't drain out. Right, so since it can't drain out, you get a high pressure. And that's one of the major risk factors, because that high pressure can damage the important cells in the back of the eye, which relay the information from the retina to the brain. And if those cells are damaged, then you're not going to be able to see. So what we're trying to look at is what's happening that causes that damage in those drainage structures in the first place, and how can we stop it?
And the two things you're looking at that might be?
Are these two signaling pathways, TGF-beta2 and TLR4, which are important molecules within the TM that when they get out of control, you get increase in all these products in the TM that build up in those structures, and then that fluid can't flow out.
So what about growing up in Wausau has brought you to today?
Well, growing up, I think it was always an expectation that I would go to college. It was never a question on whether I would go or not. I think it was just something my parents expected me to do.
What have you learned lately?
Learning that collaboration is key, and having good people around you can not only make your work better, but it can make everybody's work as a whole better. So I think that, and that's really where I think science is going in the next few years and in the next decades, is it's going to be the collaboration, working together. What can we do as a whole that will boost our discovery of new glaucoma genes and pathogenesis?